Hi guys, welcome back to my YouTube channel. In this video, we are going to see about logic gates. What is meant by logic gate? Logic gate is a device that acts as a building block for the digital electronic circuits. They also perform basic logical functions that are the fundamental to the digital electronic circuit. Logic gates makes decisions with their combination of digital signals coming from its input. Most of the logic gate have two inputs and one output. Logic gates uses binary numbers such as 0 and 1. Throughout my explanation, I am going to use the binary number 0 for off and the binary number 1 for on. Logic gates are used in the circuits involving computation and processing. They are also used in push button switches and they are used in the functioning of street lights. They are used in burglar alarms, washing machine, etc. In this video, we are going to see about one of the logic gate called NOT gate and we will discuss few questions about the combination of logic gates. Let's start.
Here is a simple electrical circuit which can be used to study the working principle of a NOT gate. This is not an electronic circuit, it is a simple electrical circuit. It is actually not a gate, but to study the function and to detect the truth table for easy learning purpose, we can use this circuit to learn about NOT gate principle. You can see a switch and bulb which are connected to a power supply. You could see close look at this switch. Right now the switch is at 1. 1 means throughout my explanation I am going to use the binary number 1 for on and the binary number 0 for off. Here you can see right now the switch is on, but the bulb is not glowing. NOT gate will have one input and one output. So here this is input. This switch is an input A and here the bulb is the output Q. So right now the switch is on. So input is on, but the bulb is not glowing. So output is off. Let me change the input as 0. You can see now I am going to change 0. Now the bulb is glowing. So when the input is 0, output is on, that is 1. So in this way the NOT gate works. NOT gate only consists of one input and one output, and if the input is on, output will be off. If the input is off, then the output will be on. It is called as a inverter gate. This is the circuit symbol of NOT gate. In this way, NOT gate works in electronic circuit. I hope you got it.
Let's try few questions from logic gates. Try this first question. Which symbol represents a NOT gate? Your time starts now. The correct answer is D. Try this second question. The diagram shows a combination of logic gates. Input P is at a logic state 0 and input Q is at a logic state 1. What are the logic states at output X and at output Y? Your time starts now. The correct answer is A. Let's see. Here input P is 0 and this is a NOT gate, so the output will be 1. And here input Q is 1, so another input for this NAND gate is 1. So for NAND gate, both inputs are 1, 1, so the output will be 0. So output X is 0, and this is NOR gate. So one input for NOR gate is 0 and another input for NOR gate is 1. So the output of NOR gate for 1 and 0 inputs are 0. So output X will be 0 and output Y will be also 0. So the answer is A. Try this third question. The circuit shown contains 2 gates. Which truth table describes the operation of the circuit? Your time starts now. The correct answer is D. Let's see. Let's give P input as 0 and Q input as 0. It is a NOT gate, so the output will be 1. And this is a OR gate, so inputs are 0 and 1. So the output of OR gate will be 1. So first one is correct. Let's give the input of P 0 and the input of Q as 1. So when the input of Q is 1, then the output will be 0. So for OR gate, both inputs are 0, 0. So the output will be 0. So second one also correct. Let's give P input as 1 and let's give Q input as 0. For 0 Q input, output will be 1, and for inputs 1, 1 for OR gate, the output will be 1. So this option also correct. Let's give input P as 1 and input Q as 1. For input Q as 1, the output will be 0. So the inputs are 1 and 0 for OR gate, then the output will be also 1. So this option also correct. So the correct answer is D. Try this last question. There are 2 inputs to the combination of logic gates shown and 1 output. Which truth table represents the action of this combination of gates? Your time starts now. The correct answer is A. Let's see. When the inputs are 0, 0, it is a NAND gate, so the output will be 1. Then it is a NOT gate, so the output will be 0. So first row is correct. Second, input 1 is 0 and input 2 is 1. For NAND gate, output will be 1. So the output of NOT gate will be 0. So second row also correct. Then third one, when input 1 is 1 and the input 2 is 0, then the output of NAND gate will be 1 and the output of NOT gate is 0. So third row also correct. Then when the input 1 is 1 and the input 2 is also 1, for NAND gate the output will be 0. So the input of NOT gate is 0, so the output of NOT gate will be 1. So last row also correct. So option A is the right answer.
I hope you got some knowledge about NOT gate and the combination of logic gates. Thank you.